So now, some, or a lot, of example problems from section 3.3. Okay. In 5 through 12, rewrite the logarithms as a ratio of common logs and natural logs. In other words, this is the log base a of 4/5. So this is where you use the change of base formula. So that would be, in terms of common logs, it would be the log of whatever you're taking the log of divided by the log of the base. And that would be the answer to A. The answer to B would be exactly the same thing, but with one less, well, I suppose total 2 fewer letters, right? Natural log of 4/5 divided by natural log of A. All right, rewrite the expression in terms of natural log of 4 and natural log of 5. So it's natural log of 5 over 2. So we could decompose that as the natural log of 5 minus the natural log. I tend to do this a lot. I'll take my natural logs and I'll write H. Why? Because I don't know what's happening. Natural log of 2, okay? Now, here's the deal. Natural log of 5, that's fine. That is not the natural log of 4, so we have to use some trickery. All right, not trickery, some exponents. Is there a way to rewrite 2? Is there a way to take 4 and make it into a 2? In other words, is there some 4 to some power and make it into 2? Well, I want to make it smaller, so I'm suspecting that it's going to be a negative exponent, right? And that would make it 1 over 4, right? Or would it be? Oh, wait. Here's a thought. Watch this. Wait. I want to take 4 and I want to make it into 4. What can I do to 4 to make it into 2? I could take the square root. In other words, I could do 4 to the 1/2, right? So then I could write this as the natural log of 4 to the 1/2. Now, it says in terms of natural log of 4 and natural log of 5. So then what I would say we'd have to do is natural log of 5, that's fine. We just want this as the natural log of 4, which means we have to use the power rule to bring this down. So it'd be that, right? Okay, that's it. All right. Use the property of logarithms to rewrite and simplify the logarithmic expression. Okay, so I see 8 times e cubed. So natural log of 8 times e cubed. So the natural log of something times something is the natural log of 8 plus the natural log, I told you I was going to do that a lot, natural log of e cubed. Now e cubed can be simplified. These are two, we're composing two inverses. So this would be the natural log of 8 plus 3, just like that. Maybe just to be clear, we could do it like this, or we could do 3 plus the natural log of 8. Either way it works. It's just we want to make sure we're just taking the natural log of 8. Similar reasoning here, except we're dividing, so its analog is subtraction. What is the natural log of e to the 5th? Why, it is 5, composing those inverses. And that's it. All right, verify. So opposite natural log of 24 equals this. Well, what I'm going to do is I'm going to try to put this together. The negatives match, right? So what I'm going to fool with, I'm not going to fool with this side. I'm going to leave this. And what I'm going to do is I'm going to do some stuff. Now, the power rule means I can bring the power down, but it also means I could bring the power up. Couldn't I? Right? Reason being is I could put these two logs together because I'm adding, but I can only do it after I have no multiples. Now, there's a couple different ways to go. What is the natural log of, well, what's 2 cubed? 2 cubed is 8. Right? And what is, well, it's 8 times 3 because it's the natural log, so I can combine it as 1 natural log, 8 times 3, which is the natural log of, hey, they match. And we're done. All right, expanding. So expanding means we take something that's relatively compact and we expand it. In some cases, there's not a lot of expansion can be done. So I see a cube root, which I happen to know is, and you will come to also, is something to the 1/3. So the expansion would be using the power rule to just write it like that, and that would be your final answer. It's as far as you can go. Okay. A little bit more going on here. We have x times y then divided by z. So could I rewrite this as, well, natural log of, so I'm multiplying the 2 on top of, but I'm dividing by z. So watch what happens. Now you may be thinking, but wait, shouldn't I have to do this, which would then be the natural log of x times y then minus natural log of z, and natural log of x, y. So what I just did is I went backwards, right? Now, with without the parentheses, in other words, most people are just going to say this is the natural log of x plus the natural log of y minus the natural log of z, and leave it. But I'm just showing you that you could group these if that's bugging you. All right. This is more complicated because we have exponents. That's to the 1/2 power. So what do we have? We have natural log of x squared over y cubed, but it's being raised, both of them, to the 1/2 power. Notice how it's stretched over both. Okay. So that's the same as, well, power to power. That means the natural log of x over the natural log of, natural log of x over y to the 3/2. So now we have some division going on. So I can say natural log of x minus the natural log of y to the 3/2. But then I have to bring this, in order to fully expand this, I need to bring this exponent down. So it's going to be natural log of x minus 3/2 times the natural log of y. And that would be a good final answer right there. Similar idea here. I'm going to start by putting everything in terms of, right, exponents. Do not take the square root. You just can't. You can't take the square root of this and get anything else. This is as much as you can do. But you can then, because you're now dividing, do that. And then, this is the last step that a lot of people miss, you must bring down any exponents as multiples to have a proper and full expansion. Now I should probably mention, you can't do anything with the x squared plus 1. If it was x squared times 1, that'd be one thing, but this is x squared plus 1, so there's nothing we can do. We're done. All right, same idea. Please bear in mind we're just taking the square root of x. So it's going to be log base b of, my first step is to rewrite this so everything has its exponents, which these do. These can't cancel, one's an x, one's a y. So it's going to be a log base b of, well, this times this divided by that. So this plus this minus this. Then we bring down the exponents. Please don't donate points to me on a quiz or a test by not bringing down the exponents. This is the proper final fully expanded form. I would agree that I think you're recording this thing way out there, right? Okay, condensing, going backwards, as in making it into a single log, in this case log base 7. There's not much to be done here. Now remember, z minus 4, when we take the log of that, there's nothing special about subtracting for the log of, but we could bring the exponent up. Right? You could leave it like that. I could see your book doing something like this, though. Right? Because over 2, that's 1/2 power, it's the square root. Either one of these answers is fine, though. I'll accept either one. Okay, look, we are subtracting, but before we can subtract, that is combine these by dividing, we have to deal with this 2. We had to bring the 2 up. So our first step must be to do that. Now, if you want to distribute that out, that's your business, but I wouldn't recommend it. Why bother, right? Because you could just write it, and I think this is a little bit nicer. Yes, more condensed looking, just like that. And that would be it. Why? Because when subtracting becomes division. All right, more examples. Now, key thing, you must bring any exponents up first. Just like in the last step when you're expanding is to bring the exponents down. First thing you have to do is bring the exponents up. Bring in the exponents, they say. Then you can combine these. Plussing means timesing, minusing means dividing. So natural log of x cubed times y squared all over z to the 4th. That's it. Okay, pay attention to parentheses, please. So what I'm going to do is I'm going to do 4 times, I'm going to combine these two as the natural log of z times z plus 5, right? Just like that, minus the natural log of z minus 5, which is fine. So I did this in the parentheses first. Now I'm going to bring up the exponent. bring up the exponent. Now here's the problem. I have to be careful. What am I raising to the fourth? And the answer is everything. You see what I did there? We often use brackets to differentiate them from the, right? Now, could you say, hey, that's z squared plus 5z, right? So say this is z squared plus 5z, and say that's to the fourth. Instead, sure. That might actually be a little bit easier, right? And then, because you're subtracting two natural logs where there are no multiples in front, so you can go ahead and combine this into a single expression. Just like that. And that is all, that is that, okay? Home stretch. So, parentheses, or in this case, brackets. So you're going to condense all of these, and then multiply the mess. Now here's the problem. We're dividing twice. How does that work? Well, it turns out when we're dividing twice, all that's happening is we're adding this to this, right? So if I do 1 divided by 2 divided by 3, well, 1 divided by 2 is 1/2. Then I'm dividing by 3, which is 1/2 times 1/3, which is really 1/6, or 1 times 2 times 3. So I'm dividing twice like that, right? See the analog there? Just means I'm inserting that in the denominator. Now, here's what I'm tempted to do. Ready? 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 Natural log of x over x plus 1 times x minus 1, that's x squared minus 1, right? Still times 2. That way, when I bring this up, it becomes x squared over x squared minus 1 squared, just like that. That'd be the preferred way of doing that. Because remember, you have to square both things, okay? That's it. All right, evaluate these. In other words, use property of logs to evaluate. So log base 5, I want to put this in terms of 5. I know 1 over 125 means I must have taken the, well, 5 and raised it to some negative exponent. So it turns out that 5 cubed is 125, which means my final answer is that, composing the bases, composing the inverse of each other. Log base 4 of 16. So this is where we recognize this as this, we hope. There's no way to take positive 4 and raise it to anything to get 16, negative 16, sorry. The other way to look at it is the domain of any logarithmic expression has got to be 0 to infinity, and this ain't 0 to infinity. All right, log base 4 of 2, I could do the square root, that'd be fine. Log base 4 of 32, let's try this. Let's put it into a single expression, which would be 2 times 32, or 64. Now, believe it or not, 4 times 4 is 16. Times 4 is 64. No, I'm actually in the middle of a video. So this would be e to the, I'm almost done. E to the 3/5, because remember, taking a fifth root, 1/5 power. So these just cancel. Final answer, 3/5. And that actually is it.